So far whatever we have learned, are you guys clear about it? Is there anything that is confusing or not making sense or something that is difficult to digest and process? No? Okay. So we will continue with what we have been doing. We have started with geometry. So where we started with the line segment, line, rays, then we went to angles. Then we learned about the three types of angles: acute angle, obtuse angle and right angle. Acute angle is the angle smaller than 90 degree, right angle is a 90-degree angle, and obtuse angle are the angles greater than 90 degree. Then we went on to learn the shapes with three sides, and that is when our journey started with closed shapes. First thing we learned about was triangle. So triangles are the shapes with three sides, closed shape with three sides. Yeah. And then inside the triangle we learned the properties that you can categorize triangles into three types based on sides, and those are called equilateral triangle, isosceles triangle and scalene triangle. Hey Gitesh. So after the triangles, and then based on the angles we learned that there are three types of triangles. One is called acute angle triangle, where all the angles are less than 90 degree. Right angle triangle, where one of the angle is 90 degree, and the obtuse angle triangle, where one of the angle is more than 90 degree. Hi Pranav. So everybody is here, I think, in the class. Only person missing is Bibhuvan, I think. Okay. And who else? Okay, fine. So this was on the triangles properties. Then we started learning the properties of quadrilaterals. Quadrilaterals meaning the shape with four sides. That is where we learned about the rectangles, squares, rhombus, kite, trapezium or trapezoid. What else? That's it? Yeah? Okay. And parallelogram. That's why I was thinking there's something that we are missing. So these are things that we have learned so far, and we have just learned the property of these shapes. What we started with yesterday was we started talking about the perimeter. What is our understanding of perimeter? That is when we learned about the perimeter of rectangles, squares, and any shape, right? We picked up a very unique looking shape like this and said find out what is the perimeter. We just added all the sides and found the perimeter for that. All these things you guys remember, right? Or you forgot something? Everything you remember?
Yes.
Okay, wonderful. And if you forget, you have a virtual teacher with you always. That is the video of my class which I upload on YouTube, and you all should have access to that. It is not because I'm a YouTuber, I'm trying to get views or do anything about it. It is only for my students here, all my kids here. This video that I upload on YouTube is only meant for you guys to go through it whenever you want to revise something that we have learned and we tend to forget, okay? And if the virtual teacher is not helping, the actual teacher is always there. You can reach out and ask questions, okay? So let's continue. So today we are going to talk about the area of different shapes. We'll start with the quadrilaterals, then we'll go to triangles, and then we'll look at some compound shapes. We might not be able to cover everything, but we'll see how much we are able to cover today. Okay? Yeah?
Yeah.
Alright. So we're starting with quadrilaterals. Let's look at what is this called? Rectangle?
Yes.
This doesn't look like rectangle because my drawing skills are not as good as Myra's. Myra does much better drawing than me, and I'm sure you guys do the same. But anyways, believe me, this is a rectangle, okay? So when we say rectangle, the first thing that comes to our mind is the opposite sides are equal and parallel, and every angle is 90 degree. That's the property we know. Now, let's look at one small thing before we move on. What is this? I will say this is 1 centimeter in length, 1 centimeter in width, all sides are 1 centimeter. Okay? What this can be called? A square with 1 centimeter or a 1 centimeter square. This baby square that you see here, this is 1 centimeter in all sides. Okay? We will call it 1 centimeter square, a square with 1 centimeter. Is that okay? Yeah? Now, let's look at this. This is my rectangle, which is, let's say, 6 centimeters in length and 3 centimeters in height. Okay? What I am trying to do is, I am trying to draw lines so that I can break it into like this baby squares. Okay? Every baby square is 1 square centimeter. Okay? 1 centimeter square. Yeah? Now look at this rectangle. What did I do? I drew lines to make those baby 1 centimeter squares. Okay? How many 1 centimeter squares do I have here? This was 6 centimeter in width and 3 centimeter in height. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 1 centimeter square. Okay? Okay? Or I will not write even 1. I will say it is 18 centimeter squares. These are the squares which is with 1 centimeter or centimeters. Yeah? 18 1 centimeter squares. Okay? Now, what will we do? So this is 18, 6 times 3, okay? Now, if my rectangle was that my length was 6 centimeter and my height was 2 centimeters, how many squares did I have? 12. That is 6 into 12. Yeah? 6 into 2, sorry. Yeah?
Yeah.
So what you see here, if I have, so here my, how many square centimeters I have? 12 into 1 centimeter square. Yeah?
Yeah.
So that gives me the formula. Let's say if I had, if the length was 4 centimeters and width was 2 centimeters, how many centimeter squares I had? 8. So it is 4 into 2 centimeter squares. Yeah?
Yeah.
So my English is becoming my maths now. Whatever is my length times my width is giving me that many square centimeters. My square centimeter is by 1 unit, 1 box. Yeah? So this gives us the formula for area of a rectangle. Length times width. When I had 6 and 3, it became 6 into 3. When my when length was 6 and width was 2, it became 6 into 2. When my length became 4 centimeters and width was 2 centimeters, it became 4 into 2. When I had 3 centimeter length and 2 centimeter width, it became 3 into 2, 6 boxes, 6 centimeter squares. So that gives us the formula for area of a rectangle. Let's say this is length and this is width. So area of a rectangle will be length times width, centimeter square. Centimeter square I am telling you only because I'm able to relate to that box thing that you were seeing. This is not the case always. It will be a square of the unit. So let's say if your length is 5 meter and width is 2 meter, your area will be 5 into 2 meter into meter square. This centimeter square is only your way to relate, only a way to see, okay fine, if I have a rectangle, how I can break it into smaller 1 unit squares and then find out the total area. Yeah?
Yeah.
Everybody with me so far?
Yes.
Okay. So this becomes our formula. Says what area of a rectangle is length times width. That's it. Yeah?
Yeah.
Now rectangle and square are cousins, if not siblings, okay? Because they have a lot of things in common. If I look at a square, here length, opposite sides are equal, all angles are 90 degree. It is something similar to rectangle only. Just that in rectangle your length and width are different. Here your length and width are same. So you can use the same property here. What happens to area of a square? That is length times width. Length times width. Width is also same as length. It becomes length square. Yeah? That is the area of a square. Now let's do some sums, okay, before we go to learning something more interesting, a little complicated, meaning we learn some more properties. We call it theorems, okay. I know this, you guys might not learn it at this age, but this is very important because I would want you guys to know about those theorems so that when you see the formula, it should not look like the formula has come from the sky as a gift. There is no formula in math that comes on its own. It is derived. Okay? So I'll explain you guys how it is derived. Some of you will be able to follow, some of you will not be able to follow, but when you watch the video again, you might be able to follow it better. And even if you don't do it, at least you'll memorize the formula, but you will not memorize it like that, okay, I have to memorize it. You will know that, okay, there's a reason for it, and I can refer to this video or I can refer to what I have learned in the past to be sure that, okay, this is how it is derived. So let's do few sums first, okay? I have a rectangle with length of 12 centimeter and width of 5 centimeter. Find out the area and perimeter for this one. This is first question. Second question is, I have a square with area equal to 25 square centimeters. Okay? Find out the length of each side and find out the perimeter. I want you guys to solve this sum, these two sums. Okay? First sum is, there is a rectangle with length as 12 centimeter, width as 5 centimeter. Find out the area and the perimeter. Area equal to what? Perimeter equal to what? I'm sorry? Oh, everybody has done it? Okay, let me complete the second question. Second question is, I have a square whose area is 25 centimeter square. Find out each side, length of each side, and tell me what is the perimeter. Okay, so who has solved it now? Okay, let's see what is Divyanshi saying. How much is the answer? Which one? First one? Divyanshi, unmute yourself and tell me what is the answer for which question it is. Or who wants to tell that? Divyanshi is still on mute, beta. You have to unmute yourself and then tell me how much is the answer. I cannot hear you, Divyanshi. You are on mute. Vivan, do you want to tell? Yeah, go ahead.
I'll answer for the first question.
How much is that?
The area for the first question is 60.
What is that? 60.
60 centimeters.
60 centimeters. Okay.
And the perimeter is 34 centimeters.
34 centimeters. Anybody has a different answer? Yes. Yes, Sherry.
I have the answer for the second question.
You have the answer for second question. What is it? Okay, what is that?
The length is 5 centimeters.
Okay. And what is the perimeter?
The perimeter is 10 centimeters.
Okay, very nice. 20 centimeters. Okay. Anybody has a different answer? Yep, yep, and up.
I was going to
Same thing. Louder, I cannot hear you, Pranav.
No, I don't have a different answer.
You have the same answer? For which one? First one, second one? Both of them? Okay. Let's see what Gitesh has to say.
For the first one, the area I got 60.
60 what?
60 centimeters square.
Centimeters square. That is what I was waiting for. So when you say area equal to 60 centimeters, I will not agree to any of you, okay? So area cannot be in centimeters or meters or millimeters. It has to be always square. Square of something, okay? Okay, so we will come to that.
Perimeter is
Uh-huh.
17 is centimeters.
Perimeter is how much?
17.
17.
Oh, sorry, not 17. I did it wrong, sorry.
How much is that?
Not 17.
Okay. So Vivan has told, Pranav has told, yeah, 30? 34. Okay, so no new answer, so I'm not writing it. Okay?
Then for the second question, I got 5
5 what?
centimeters square.
No. 5 centimeters. You are talking about length. Length cannot be in centimeters square, it has to be centimeters, okay? No, so see, these are the minute things, but very important. If you ever miss the square or you say square extra, that changes the meaning. So just be a little careful with that. So length is 5 centimeters. What about the perimeter?
Uh, 20
20. 20 what?
centimeters.
20 centimeters, yes. Okay. Anybody is still solving or trying to find out the answer? Gaushika, Myra, Sagarika, did you guys get any different answer? No? Okay. Now, so the first one, when you got area as 60 centimeters, that was not right. It has to be 60 centimeters squares. Now how? See, look at this one. I know most of you have done it, but as a teacher, right, it's my job to solve it for you, and I keep on saying that I don't trust anybody, and so has to be the case with you guys also. Even if your best friend says that trust me, this is the answer, say no, I would not. I will solve it myself and find out if what you are saying is right or not. You might be right. Let me validate. Because when it comes to math, I don't trust anybody. Not even my family members. Yeah? So, here's the thing. Area, we know that is length times width. What is the length here? 12 centimeter. Into width. What is the width? 5 centimeter. So this means 12 and 5 I can multiply. 12 times 5 is 60. That part is okay. Everybody did it right. I have centimeter and a centimeter. Centimeter into centimeter becomes centimeter square. Like you say x into x is x squared, y into y is y squared, centimeter into centimeter is centimeter squared. That's how it is. So that is what you have to take into account. Don't ignore the unit. There might be situation where you'll be given a question saying, okay, length is 12 centimeter, width is 5 millimeter. Then you will not multiply millimeter and centimeter. You will convert them all into one unit first and then do your calculation. Okay? So that's why taking a note of the unit is very, very important. Be extra careful. That's very important. Okay? Now, perimeter. Perimeter is, okay, now we know it's a rectangle. This is 12 centimeter, this is 12 centimeter. This is 5 centimeter, this is 5 centimeter. So my perimeter is sum of the length of all the sides. So 12 centimeter plus 5 centimeter, 17 centimeter. Plus 12 centimeter is 17 plus 12 is 39 centimeter. Plus 5 centimeter is 34 centimeter. So perimeter is equal to 34 centimeter. So that is why this is 5 centimeter plus 5 centimeter, 10 centimeter. So centimeters, you are talking centimeters. If the units are different, you have to convert them. Okay, so always don't lose your focus from the unit. Keep a very close eye on the unit. Okay, that's important. Now, the next one. Area is 25 centimeter square. What is the side and what is the perimeter? Same thing. You know that area equals to length into length for a square. So 5 into 5 square gives you 25 square. So length is 5 centimeters. Perimeter is 4 times the length. It's a square, right? So 4 times the length. 4 into 5. Everybody got it right. So I'm not deliberating on that one. Only thing I have to tell you guys that make sure that you don't take your eyes off the unit. Pay a very close attention to the unit. That is the key. Alright. So these were two of the sums that we wanted to do, and obviously we'll do more assignments. Let's look at what else we want to do. One second. Now, I'm just trying to see if I want to just to do another sum, or I should start teaching you guys something interesting. Okay. Now, we looked at the area of square. We looked at the area of a rectangle. Let's look at area of a right angle triangle before we do something more complicated. Whatever you see here, let's say A, B, C, this is a right angle triangle. Okay? What did I do? I created a mirror image of this along this line. I created a mirror image of this. Now when I look at the triangle, the right angle triangle and the mirror image of this, what does it look like? A rectangle? Yeah? So, that's it. When I look at it more carefully, what do I find here? This guy and this guy has the same area, means the same space, because they are the mirror image. Yeah? So if I look at only this area, this will be half of the total area that you see. Yeah? Do you guys agree? You don't?
Yes, I agree.
Agree? So again I'm repeating. I have a right angle triangle. What we did was, we created a mirror image of this. We created an image of this and we flipped that and aligned it so that it looks like a rectangle. Now, what that means is my area of this triangle, the right angle triangle, is half of the area of the rectangle, right? If in my right angle triangle, if I call this as base and I call this as height, if I look at the whole rectangle, that is what? Area of rectangle, let's say this is D, A, B, C, D, will be B times H, this is the length and this is the width, yeah? While the area of my right angle triangle will be half of the area of this rectangle. What is the area of the rectangle? B into H, half into B into H. So that is how the area of a triangle or a right angle triangle comes as half into base into height. Anybody has any questions so far? I see people are paired with what? Varun Mukamma. Okay, I don't know. That's fine. I see Vivan and Gitesh showing a different sign there, saying paired with something. Okay. Coming back to this one. So the area of a right angle triangle is half into base into height. And how is that possible? Because when we visualize this, when we create a mirror image of this, then it looks like a rectangle, and we all know that area of a rectangle is base, height, length into width, or here we are calling base into height. So the area of a triangle will be half of the area of the rectangle, which is half into base into height. That formula is fine? Are you guys agreeing with me? So again, area of a right angle triangle is half into base into height. You all know it. Hundreds of people would have told you that. Every book says so. But I was wanting you guys to visualize and figure out how is that formula coming to picture, right? And that is when you visualize this, then you will see that, okay, my right angle triangle, if I create a picture of that and align it, it looks like a rectangle. So my triangle is actually half of the rectangle that I see in the frame. That is how half the area of a rectangle, half into base into height. That's it. Yeah? So far so good? Okay.
Yes, sir.
Okay. So we have so far learned the area of a rectangle as length times width, area of a square as length times length, and area of a right angle triangle as half into base into height. And I have not asked you guys to memorize it. We have seen it, how it happens. We have tried relating that with some examples so that it's easy to understand, right? And when you do more practice, this formula will come easy to you. You don't have to memorize it. Now let's learn something that we need to learn to be able to look at the area for other shapes. Do you guys know what is congruence? What do you mean by congruence? Have you heard of something called congruent? Something as congruent or something, a property. Yeah,
Equal?
that could be one example, one answer. What else? Myra? Huh? Myra, your voice is very low. You have to be a little louder for me. Not exactly, but yeah, I will take it partly, okay? Yeah. I want to hear more answers. Okay, who wants to go next? Okay, yeah, Deekshita.
If a shape divides into half,
No, that is not congruence. So, okay, now let's look at this. If you look at my hand from this side, what do you see? It looks like I'm worshipping, right? Now if you look at this, what do you see? it looks like only one hand. Yeah? If I flip this, what does it look like? Only one hand. If my hands were not of the same size, this is how it would have looked. Yeah? It would have not looked like a one hand. Yeah? Goshika, you were saying something better. Go ahead. I'm sorry? You?
Absolutely.
Oh, okay, that was fine. So, again, I'm worshipping. You guys can see both the hands. And both the hands look to be of the same size from this side. If I flip, you can see only one hand. You don't know if I'm hiding another hand behind my first hand or not. It might be one hand like this, or I'm hiding another hand behind this. But you can only see one hand. I flip this. What do you see? You are seeing one hand. It might be one hand like this, or it might be two hands where I'm hiding one hand behind it, right behind it. But there is no magic. These were two hands. But when I put them together, it could overlay each other completely. It could overlay each other completely. That is what is called congruent. They have exactly same properties. They can hide each other. If this hand can hide this hand can hide this hand also. Both the hands are congruent. Now if you look at these two triangles, are these congruent? No. Because this triangle can hide this guy, because this guy is a baby who can hide behind this guy. Imagine this guy trying to hide behind this guy. How will it look like? Yeah? It's like a very, very small animal, like a rabbit trying to hide behind an elephant versus elephant trying to hide behind a rabbit. Yeah? So these are not congruent. Congruence is a property where two shapes are supposed or are called to be congruent when each of them can hide each other. Okay? It cannot be one way. This guy can be hidden behind this guy, but the vice versa is not true. So that is why we will not say that these two are congruent. Okay? Now, I have a triangle like this, and I have a triangle like this. And when I hide this guy behind this guy, or hide this guy behind this guy, it's exactly the same. Meaning both are able to hide each other. They are congruent. Okay? So when two shapes, any two shapes are congruent, that means they have exactly same property. Now look at this guy. When you say this and this are congruent, that means they have exactly same property. Meaning one side of this will match with this side. One side of this will match with this side. One side of this will match with this side. One of this side will match with other side. So they have one thing matching with each other. Okay? They have, so one of the angle will match with one of the angle here. One of the angle will match with another angle. This angle will match with this angle. This angle will match with this angle. So when you prove something as congruent, if you find two shapes congruent, that means they have exactly matching properties. Their area will be same. Their dimensions will match. Their sides will match. Their angles will match. Their family will match. There is no family here. I was just kidding. So what I'm saying is, when two shapes are congruent, they have exactly matching properties. Exactly matching properties. Okay? That is the basic of congruence. Now, by any means, by hook or by crook, if I ever prove two circles to be congruent, that means they have everything matching. Then I can say, okay, these two are exactly the same thing. So if this is this, this will also be this. If I say two triangles are congruent, that means the sides will match, the angles will match, and the area will be the same, the perimeter will be the same. That means congruence means exactly the same. If I ever prove that two things are congruent, that means they are exactly the same. That's how we will relate it, okay? So in future, if I ask you, or if anybody asks you, what do you mean by congruence? You will say that anything that is congruent, that means they are exactly the same. Exactly the same. Okay? So far so good?
Yeah.
Okay.
So it means the same or equal.
Same. Same is equal, no? If my age is same as you, that means my age is equal to your age. Yeah? Okay? So, I know this is okay to have questions, and this is a valid question, but for the sake of simplicity, if two things are called to be congruent, then you can assume that they are exactly the same, they have every property matching. That is why I was emphasizing so much on the property of the shapes for initial two classes, right? You guys would have thought that, okay, this gentleman is wasting my time by talking about properties. But properties are very, very important, because property is what helps you visualize any object, visualize a shape, and then come up with your plan for how you want to deal with it. Okay? Now, so we just learned about what is congruence. We will learn one theorem for congruence today. Okay? When we say theorem means a universal truth that you can prove. If I say, I will give you a theorem, meaning I am giving you a theorem is derived from theory. Okay? Theory is nothing but a concept. If I say I'll give you a theorem, meaning I am giving you a concept that you can relate, that you can prove. Okay? Yeah? So there is one theorem that I will tell you guys now. And again, these theorems you are not supposed to learn in 6th grade or 5th grade. You might end up learning that in 8th or 9th grade. But it's important to understand what is the meaning of that. Okay? You don't have to worry too much about how to prove it. But if you know the basic concept, it helps. Now, and there are total 4 theorems about the triangles that will be very handy for us. Let's look at that. First theorem is called SSS, meaning side, side, side. What it means? If there are 2 triangles with all the 3 sides matching with each other, meaning if I have triangle A and triangle B, one side of this triangle and one side of this triangle, meaning S, one side is matching in both the triangles. Second S says, second side is also matching in this triangle. So 2S has matched. 2 of the sides have matched. And S, third. So SSS means if 3 of the sides in 2 triangles have matched, then the triangles are congruent. Okay? Meaning, if you ever have 2 triangles with matching length for the 3 sides, triangle A says 3, 4, 5, triangle B says 3, 4, 5 centimeters. They are matching, meaning they are congruent triangles. They are the same triangles. Vivan, where are you going? We will finish the class in another 10-15 minutes, okay? Don't worry, okay? So I'm just trying to emphasize on this congruence thing. So one theorem of congruence is called SSS, meaning side, side, side. This applies for triangle, saying that if there are 2 triangles where every side matches with another side in the second triangle, then the triangles are congruent. Now I'm giving you guys a challenge that try drawing 2 triangles with matching side length and they don't overlay each other. Try drawing a triangle, okay, when you are wanting to play with maths, okay, in your free time outside this class. Try drawing 2 triangles with some length, okay, where the sides length are matching, and then you cut the triangles and try to see if you cannot overlay them. Okay? Not right now, maybe after the class. This is just a task, a playful task. Yes, Gitesh.
Can I go to the restroom?
Yes, please. So, this is the first congruence theorem that says that if you have two triangles with matching sides, one triangle one side, second triangle one side matching, first triangle second side of the second triangle matching, first triangle third side, second triangle third side matching. If these two are matching, the triangles will be congruent. That is what I want you guys to memorize and remember. So that is SSS. That is the first theorem. If I give second theorem, that says SAS, meaning one side and the angle, with two sides and the angle between them. If there are two triangles where, okay, if there are two triangles like this, and one side, second side, and the angle between them. One side, second side, and the angle between them. So this side matches with this side matches with this side, and the angle matches with this angle. The angle between them. Then the two triangles will be congruent. This is the second theorem. So there are four theorems like this. I would just want you guys to understand what those theorems are. You don't have to prove it right now. You will anyways prove it when you go to 8th or 9th grade. So don't rush for it for now. But these are the four theorems that I would want you to just keep a note of. SSS, second is SAS, third is called ASA, and fourth one is called RHS. So this one is only for right angle triangle, okay? So we'll come to this later. These are the three theorems: SSS, SAS, ASA. These are the three theorems for proving the triangles congruent. We will talk more about it in the next class. If I go talking about it now, I'm sure you guys will start scratching your head. This is a loaded discussion, okay? So I don't want to stress you guys out by talking about it in this class. But the only theorem that I want you to remember, at least from this class, is SSS. Meaning if there are two triangles with three sides matching, that means those triangles will be congruent. Okay? And do you guys remember when I say congruent, what does it mean? They are exactly the same. They have every property matching. Okay? So you just looked at three sides and found the three sides are matching. That means you are saying that they are congruent, and then you will start saying, okay, their angles are also the same, their area is also the same, their perimeter is also the same. That is what will be the interpretation from this. Okay? So that is about congruence. Now, let me teach you guys something interesting for next 5 minutes, and then you guys can enjoy rest of your weekend. Or let's do some playful thing. I say that, okay, there is a triangle where one side is 3 centimeter, second side is 4 centimeter, and third side is 8 centimeter. Can you guys draw this kind of a line, a triangle? Try drawing a triangle with a scale or something where one side is 3 centimeter, second side is 4 centimeter, and third side is 8 centimeter. Can you draw a triangle like this? Let's see if you are able to do that. This looks like a very easy thing. Can you draw it? Let's see. And once you are ready, let me know. I'm just If anybody can draw this triangle, I will give $10 as a prize. I'll tell you why see, I should not be talking about money, but this is more of a challenge.
Can you repeat it again?
3 centimeters, 4 centimeters, and 8 centimeters. I know I'm tricking you guys. So I will see. I knew that I never wanted to give any money to anybody, right? I had no plan of giving $10. Yeah?
You can.
You can. You can. Okay? So that was the message. Okay? I mean, obviously, I'm sorry for talking about money with you guys. I'm not supposed to. But if I have to give a prize to anybody, I'll talk to your parents, not to you. Okay? So, but yeah, that was more of a challenge. I was saying that you cannot draw a triangle where sum of two sides is less than the third side. Okay? Yes, ma'am. You are asking some question? Any questions? Pranab, mommy wants to ask some question. Please ask her to. Please let her ask. That's okay. No?
But she's just watching.
She's just watching me. Okay. Okay. So what I was trying to say here was that if you have to draw, okay, let's look at this. If anybody says the sum of all the angles of my triangle is 180 degree, that guy has studied maths. I will agree. That is possible. If the same person says, I have a triangle where sum of all the angles is 181 degrees, I will not be friend with him, because this is not possible at all. There cannot be a triangle with the sum of all the angles not being equal to 180 degrees. It has to be 180 degree or it cannot be a triangle. As simple as that. If it's ever 179 degrees, that is not possible. If it's 181 degrees, that is not possible. Same way, second theorem is that sum of your two sides has to be greater than the third side always. Okay? Sum of any two sides. Now, whenever you come across any triangle, pick any two sides, add it together. The sum of the two sides will never be greater than the third side. Sum of the two sides will always be greater than the third side. If sum of the two sides is less than the third side, that means you cannot draw that triangle. So that's why I was giving you as a challenge that okay, draw a triangle with 3, 4 and 8 centimeters. See here, sum of these two sides is equal to 7. It is less than the third side. You cannot draw. See, if it was 4 and 8, would have been 12. Is greater than 3. This is fine. But then you have to look at all the combinations. So there are 3 combinations, right? Let's say you have A, B and C, 3 sides. You will say A plus B and C. Is it greater than C? You will look at B plus C and see if it is greater than A. You will see add A plus C and C is greater than B. Any of the 3 combinations, if it is not true, see here it was A, B and C. A plus B, 3 plus 7, 3 plus 4, 7 was not greater than 8. First condition failed, you cannot draw. Even if the other 2 condition passes, then also it will not work. So basically what I am trying to say is, if you are talking about a triangle, you have 3 sides. Sum of every 2 sides that you pick up will be greater than the third side. Any 2 sides that you pick up will be greater than the third side. You can give this challenge to anybody, okay? Saying draw a triangle where 2 of the sides sum of the two sides is less than the third side. Just pick up any number which meets that condition and see if that person is super intelligent to draw it. If they draw it, the whole math proves wrong. Okay? It's not possible. Okay? That's the message that I wanted to give. So two things take away from this property that we have learned. One is sum of all the angles will be 180 degree only for a triangle. And second thing is sum of any two sides, you can literally play with it. Sum of any two sides has to be greater than the third side. If that is not the case for any combination, that is not a valid triangle. Okay? So that is all we had for this class. So today what we did, we talked about how to find out the area of a rectangle, how to find out the area of a square, how to find out the area of a right angle triangle, and then we learned a little bit about a theorem we learned about what is congruence in practical terms, when you saw me worshipping and then flipping my hand, and we learned what is congruence, and then we learned about one of the theorems for congruence called SSS, and this is the theorem of congruence for triangle, which says if there are two triangles with matching all the three sides, then they are congruent, meaning they will have each and every property matching. They will have the area matching, they will have the perimeter matching, they will have the angles matching. Okay? So that is one theorem that we learned, and we briefly talked about the other three theorems we have, which is called SAS, ASA and RHS, and we have not talked about these three theorems, which we will talk about in the next class. And again, there is no complex thing about that we have to learn. We have to just know what these theorems are and how we can apply those theorems to find out the area of the other shapes that we'll talk about in the coming classes. Yeah? So that is what brings us to the end of the class. Any questions, anything that we could not understand, anything that I did not explain you guys well, let me know. All good?
Yes, sir.
Okay? Okay. Thank you so much. Enjoy the rest of your evening. Talk to you guys next Saturday. Wait for the link of the video, which I'll upload soon. Maybe by tonight, maybe by tomorrow. And then I will send out assignment for you guys, for you to practice and have fun with them. Like Vivan is having already fun. Take care. Alright, bye-bye. Bye-bye.
Bye.